In this section of the course, we discuss systems of units. System of units is the engineering language that is understood globally by engineers when they quantify any physical property. There are many systems of units, but in electrical engineering, we use International System of Units, which are also known as SI standards. In International System of Units, there are 7 fundamental quantities and their units. These quantities are length, mass, time, electrical current, temperature, luminous intensity, which is intensity of light, amount of substance, which is the unit used most commonly in chemistry. And these are the units for these quantities: meter for length, kilogram for mass, second for time, ampere for current, Kelvin for temperature, candela for luminous intensity, and mole for amount of substance. And the symbols are given in the third column of this table. Apart from fundamental units, there are also some units which are derived. These units are derived from fundamental units. Now this table represents the derived units which are used in electrical engineering. The quantities which are driven, which have driven units are capacitance, charge, conductance, energy or work, frequency, impedance, inductance, power, reactance, resistance, and voltage. These are the most common units which are used in electrical engineering. Unit for capacitance is farad, unit for charge is coulomb, unit for conductance is Siemens, for energy joule, frequency hertz, impedance is ohms, inductance Henry, power watt, reactance ohm, resistance is ohm, and voltage for volt for voltage. And we'll come across these units. Now, sometimes we use bigger numbers to represent quantities, and sometimes we use smaller numbers. Those numbers are multiple of tens. To represent high value of the physical quantity, we use higher powers of 10, positive powers of 10, kilo, mega, giga, tera. To represent smaller quantities or smaller values of physical quantities, we use powers, negative powers of 10, milli, micro, nano, pico, femto. And we use these prefixes instead of using 10 to the power. Now note here, all the powers of 10, they are in the multiple of 3. So for kilo is 3, and for mega is 6, for giga is 9, for tera is 12. And similar way in the negative exponential terms, they are also multiple of 3s. So for smaller quantities and for larger quantities, we can use these prefixes to represent the values. Most often you will encounter capacitance in the range of pico, nano, or micro. You will encounter inductance in the range of milli, micro. You will encounter resistances in the range of kilo and mega. Currents are normally from nano to kilo. Very occasionally you have mega. Power is in the range of mega, giga, kilo. So you will see these prefixes often in your study of electrical systems. Now, since we know the systems, let's do an exercise. What we have to do in this exercise is you have to convert these quantities, which are larger quantities and a very small quantity, in powers of 10, and then you have to apply appropriate prefixes. The first quantity is voltage, and it's 50,000 volts. So you have to use appropriate power of 10 to represent this quantity and prefix to represent this quantity. The second quantity is ohms, and it's 25 million ohms. So you have to use this. You have to do the same thing. Use a appropriate prefix and represent this quantity as power of 10. And make sure the power is the multiple of 3. And this is very, very, very low quantity for current. It's 0.000036 ampere. So you have to represent this current as a multiple of 10, and obviously the power will be negative, but power will be a multiple of 3. And you have to use appropriate prefix to represent this value of current. Before I show you the result, I will take a pause and you can do your calculations. And I hope you have achieved the same results. Here 50,000 volts, so you can have 50 multiplied by 10 to the power 3 volts, and 10 to the power 3 is represented by prefix kilo, which is represented by symbol K. Here you have 25 million ohms, so 25 10 to the power 6, which is mega for million, so it's represented by capital letter M. And then you have 0.000036, so you have 6 significant digits after decimal. So it will be power of 10, but in minus because there's a decimal number. So it's 36 into 10 to the power minus 6 ampere. And 10 to the power minus 6 is micro. So you can represent it as 36 microampere. Micro is the prefix to represent this very small quantity. And I hope you have learned a few important things about units in this section.